In this video, we are going to discuss Runge Kutta method of fourth order. In my earlier videos, we have discussed Euler's method, in which we have seen how to solve differential equation dy by dx equals f of x comma y by numerical method, in which we have drawn graph of solution of this differential equation y equals fx, where we have chosen an initial point x0 y0 on this solution curve. Then we had drawn tangent to this solution curve at x0 y0. Then we had chosen a point x1 very close to this x0 and found the y coordinate of the point q on this curve y1 equals this y0 plus h f of x0 comma y0. Approximation of y1 was not fairly good because this error is appreciable. To reduce this error, we have discussed in another video Euler's modified method, where we have used average of slopes of lines passing through this point S and improved the accuracy still further, and we have studied the new formula for second approximation of y1 to be equal to this y0 plus h, a very small difference between x1 and x0, and average of the slopes f of x0 comma y0 plus f of x1 comma y1 of 1, which is the approximation obtained in the previous step, upon 2. Euler's modified method gives fairly good approximation in 2 to 3 iterations, but this Runge Kutta method of fourth order gives far greater accuracy compared to Euler's method and Euler's modified method in few iterations, because it uses the formulae to reduce this error to a very large extent and gives the approximation very close to the true answer. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Runge Kutta method of fourth order gives maximum accuracy of approximation of the value of y1 in solving ordinary differential equation dy by dx equals f of x comma y with the initial conditions x equals x0 and y equals y0. To find the value of y equals y0 plus k at x equals x0 plus h, where this k is obtained by 4 values of k, k1, k2, k3 and k4, where k1 is h times f of x0 comma y0, k2 is h times f of x0 plus half of h comma y0 plus half of k1 obtained in the previous step, k3 is h times f of x0 plus half of h comma y0 plus half of k2 obtained in the previous step, and finally k4 is h times f of x0 plus h comma y0 plus half of k3 obtained in the previous step. Once we have obtained the values of k1, k2, k3 and k4, we obtain the value of k equals 1 upon 6 times k1 plus 2k2 plus 2k3 plus k4, and this value of k is finally used here to obtain the required value of y equals y0 plus this k. We will apply Runge Kutta method of fourth order to find approximate value of y when x equals 0.2 and we are given the differential equation dy by dx equals x plus y when y equals 1 at x equals 0. We have f of xy equals x plus y when x0 equals this 0, y0 equals this 1, and the step width h equals 0.2. First, we will find values of k1, k2, k3, and k4, and from these four values we will find the value of k. So first k1 is h times f of x0 comma y0, which from this h times 0.2 times x0 plus y0, that is 0 plus 1, 0.2. Then k2 will be h times f of x0 plus h by 2 y0 plus this k1 upon 2, that will be 0.2 for h multiplied by 0 plus 0.2 upon 2, 0.1 plus y0 is 1 plus k1 upon 2, that is 0.2 upon 2, 0.1, that gives k2 equals 0.24. Next we will find k3, which is h times f of x0 plus h by 2 comma y0 plus k2 upon 2, that will be 0.2 for h, then x0 is 0 plus h by 2 is 0.1 plus y0 is 1 plus k2 is 0.24 upon 2, that is 0.12, and this gives us k3 equals 0.244. Next we will find k4, that will be h times f of x0 plus h comma y0 plus k3, that equals 0.2 for h, then x0 plus h will be 0 plus 0.2, y0 is 1 and k3 is 0.244, and that gives us k4 equals 0.2888. Now we are ready to find k, which is 1/6 of k1 plus 2k2 plus 2k3 plus k4. So that will be 1/6 k1 0.2 plus 2k2 0.24 plus 2k3 0.244 plus k4 0.2888. That gives us k equals 0.2428. Now we can write approximate value of y, which is y0 plus k, that is 1 plus 0.2428, that will be y equals 1.2428, which is closest to the true value of y when x equals 0.2. Next we have to solve the differential equation dy by dx equals 1 upon x plus y, where initial conditions x0 equals 0, y0 equals 1 for the interval 0, 1, and the step width h is 0.5 by Runge Kutta method of fourth order. From this we have f of x, y equals 1 upon x plus y. x0 is 0, y0 is 1, and step width h is 0.5. Since the step width is 0.5 and we have to find y when x equals 1, we have to carry out two iterations. So in first iteration A, we will find k1 equals h times f of x0 comma y0, that will be 0.5 multiplied by 1 upon this 0 plus this 1, which will be 0.5. Next k2 will be h times f of x0 plus h by 2 comma y0 plus this k1 by 2, so that will be 0.5 for h, then multiplied by 1 upon x0 plus h upon 2 will be 0 plus 0.5 upon 2, that will be 0.25 plus y0, which is 1, plus k1 upon 2, that is 0.5 upon 2, 0.25. So that works out to be 0.5 times 3. Next k3 will be h times f of x0 plus h by 2 comma y0 plus k2 upon 2, so that will be 0.5 into 1 upon 0 plus 0.25 as before, plus 1 for y0, plus k2 upon 2 will be 0.5 times 3 upon 2, that will be 0.14 times 6, that will work out 0.35294 on calculator. and finally we will find k4, which is h times f of x0 plus h comma y0 plus k3. So that will be 0.5 multiplied by 1 upon 0 plus h is 0.5 plus y0 is 1 plus k3 is 0.35294. So that gives k4 equals 0.2698. Now we will find out the value of k, which is 1/6 of k1 plus 2k2 plus 2k3 plus k4. That will be 1/6 multiplied by k1 is 0.5 plus 2 times k2, which is 0.5 times 3 plus 2 times k3, which is 0.35294 plus k4, which is 0.26984. So that gives us k equals 0.3571 by calculator. Now we will write the approximate value of y equals y0 plus k. That will be 1, which is y0 plus k 0.3571. That will give value of y equals 1.3571, which we have to use as the initial value y0 for the second iteration. If you like this video, please share this to your classmates. Don't forget to subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.